Every single day, the world generates over 2.5 quintillion bytes of data. Literally quintillions. Have you ever actually stopped to wonder how massive digital platforms handle endless streams of that data without just, completely breaking down? Think about it. When millions of us are simultaneously checking our bank accounts or filtering products on a global online marketplace or trying to transfer funds on Black Friday, how does the system know exactly what information to pull up instantly without mixing your data with someone else's? Well, the answer lies in a foundational language that quietly runs the entire modern digital economy.
Welcome to The Explainer. Today, we're going to demystify SQL. This is the invisible architecture powering the back end of massive global banks and major e-commerce giants. If you've ever wanted to understand how data is actually structured and retrieved at lightning speed, you are in the exact right place. We're going to break down the core foundations of database management, and we'll use clear, real-world examples that translate directly to the apps and websites you use every single day.
Here's our roadmap for this explainer. We'll start by learning how to talk to databases, then dive into the select command, explore filtering and sorting, discover how to combine tables with join, and finally, look at how all of this powers real-world banking and e-commerce.
Section 1. Talking to databases, connecting the digital world. Let's jump right in and see what makes modern data management possible. So, SQL. It stands for Structured Query Language. You can think of databases as the central nervous system of the digital economy. They hold incredible amounts of information, right? But without a precise way to ask for exactly what you need, that data is just locked away, completely useless. SQL is the key. It's the exact tool that banks, hospitals, and global e-commerce sites use to retrieve, update, and manage your data in literally fractions of a second. To really wrap our heads around this, let's look at a foundational piece of data, an internal employees table for, say, a major e-commerce or banking firm. Take a look at the columns here for ID, name, department, and salary. We've got John in IT making $5,000, Sarah in HR making $4,000, and Mike in IT making $6,000. Now, a real global bank might use this exact table structure to manage 300,000 employees. Or you could replace the word employees with products for an e-commerce site. But the underlying logic we're going to use here, it's exactly the same. Section 2. The select command, retrieving the data. Let's move to our first building block and learn how to actually get data out of this table.
Check out this code snippet here, the select command. This is your primary, absolute fundamental tool for retrieving data from any database. When a bank teller pulls up your financial profile, or an online store loads its huge inventory on your screen, a variation of this exact command is executing furiously behind the scenes.
Let's break down the syntax, because this is absolutely crucial. Logically, the word select tells the database what specific data columns you want to choose. Then the asterisk or star is a special wildcard character that basically just means, hey, we want everything. It tells the system to grab all available columns. And finally, from specifies the exact table name we're looking at, which for us is employees. When you click View Cart on a website, a query very much like this one is selecting all the details from your specific shopping session.
And here is the beautifully structured output that the database returns when you run that simple query. We asked for everything from the employees table, and the database perfectly delivered the complete records for John, Sarah, and Mike. It's the exact same instantaneous magic that happens when a bank teller types in your account number and your entire profile just pops up on their screen.
Section 3. Filtering and sorting. Finding what matters. Because retrieving all data is great, but when dealing with massive data sets, you rarely want to see everything at once.
This is exactly where the where condition comes in. By stating where department equals IT, we're commanding the database to ruthlessly sift through millions of records and only return the exact match. It's no longer about grabbing the whole shebang. It's about precision targeting. See how the HR department is completely filtered out now? Sarah is removed from this view, leaving exactly what we asked for, our IT team, John and Mike. Imagine applying this to an e-commerce site where you click a button to only see shoes in a size 10. That's a where clause doing the heavy computational lifting to filter out all the other products from a database of millions, and doing it in a fraction of a second.
But, filtering isn't always enough. We also need to organize things. To sort this data, maybe to see the highest earners in our banking firm, we add the order by command. Right here, we're asking the database to select all employees, but to specifically order them by their salary descending.
The key difference to understand here is the sorting logic. DESC stands for descending, meaning highest to lowest. That is perfect for a bank sorting transactions to immediately flag the largest, most suspicious withdrawals. ASC stands for ascending, sorting lowest to highest, and that's exactly what we all use when sorting products online to find the cheapest possible option. Finding fraud or finding a good deal, these two acronyms make it happen.
Looking at the result, the order by command worked flawlessly. Mike and his $6,000 salary sit right at the very top, followed by John and then Sarah. The data is perfectly organized and totally ready for quick human analysis.
Section 4. Combining tables with join. Connecting the dots. Because, let's face it, real-world databases are rarely just one isolated table.
In a real banking or e-commerce database, customer profiles might be securely stored in one table and their daily purchase history in another. To see them together, a join operation works in 3 simple steps. First, we identify a common data point, like an ID number. Second, we use that ID to conceptually connect 2 tables, like connecting an employee's table to a department's table. And third, we just merge the results into one cohesive view.
Okay, this code might look a bit intimidating at first glance, but let's just read it like a sentence. It simply tells SQL to retrieve the employee's name from the employees table and the department name from the department's table. Then that join keyword tells it to link those 2 tables together precisely where the employee's department matches the department's ID. It's really just like fitting puzzle pieces together.
And the result is this unified, seamless view. In a massive bank, this is the exact mechanism that links your secure identity profile to your daily checking transactions, merging them so the teller sees one continuous story. Here, you see the employee's name right next to their actual department name, cleanly pulled from 2 completely different places in the database.
Section 5. Powering banking and e-commerce. Real-world scale. This is where it all comes together.
The crucial takeaway here is understanding how these basic building blocks, select, where, order by, and join, actually power the modern business world at an unbelievable scale. Every time you check your bank balance, a select query is pulling your specific account details. When you filter items on an online store by category or sort them by price, where and order by commands are working tirelessly behind the scenes. And when a bank generates complex business reports, analyzing millions of transactions across thousands of branches, intricate join operations are dynamically connecting all those dots. SQL is the quiet engine running data analysis across global markets.
So it really makes you wonder about the massive scale of invisible data structures processing your daily digital transactions, doesn't it? The next time you effortlessly click purchase on a website or instantly transfer funds on your banking app, take a quick moment to picture the thousands of lines of invisible SQL code executing at lightning speed just to make it all possible. Thank you for joining me for this explainer. Keep wondering, keep learning, and I'll catch you next time.